All right, hello everyone. Welcome back to another Stat385 video. So in this video, we're going to go over the second part of Lab 5 with this S3, where we'll go over S3 object-oriented programming using R. Okay, so this video is going to be pretty long and there's going to be a lot of coding. I've gone through the lab in my own time, so I'll be often pulling code that I've already pre-written, but we'll go over some of it live as well. But I'm just giving you a heads up. Okay, so in this one, start out as we normally do. I'm in my 385R project on my desktop. I'm in Lab 5 already, and my first task is to create an R script named S3 shape. So let's just go ahead and do that. Lab 5, okay, good, off and running. Okay, so in this exercise, we'll explore using the S3 system for object-oriented programming. We'll create new classes for various shapes with constructors and validators, and new methods to existing generic functions, and create two new generic functions, being namely, we're going to create one for calculate the area and calculate the perimeter are going to be our things that we're going to do here. Okay, so consider three classes. So, we're going to basically build up from scratch what a shape is, or what a particular shape is and what a particular shape is not. And then based on the class, or we'll call each one of these shapes its own particular class. And then we will write a calc area function that is applicable to each one of these different classes, and the calc perimeter function that is also applicable to each one of these classes. Okay, so we have to create circle, rectangle, triangle for each class described above. Make a constructor named new class for each. The argument should be the elements of the relevant list, and we need to validate the class. So basically, we need to have something that creates an object in the class, and then have something that validates whether or not the object that is being created is something that is valid. So for instance, like a circle can't have two radiuses or a negative radius, stuff like that. You need to have a print method. There's a lot of stuff going on here. Okay, so first of all, let's just start from scratch. Let's just start with, I'm going to pre-organize this all. So I'm going to hit Control Shift R, which is going to have some nice commenting for different sections here. I'll just put it at the top. Okay, so we're going to have our calc area functions here. So I'm assuming that you can pause and read everything that's in the lab. Okay, calc area, calc perimeter. I think at a first pass, what I'll do is I'll do everything for a circle, and then we'll analogize to rectangle and triangle from there. Okay, so first of all, I want to essentially create a new generic function, calc area equals function use method calc area. So right now this isn't gonna, okay, so let's see what happens if I just use it. I don't think it does anything, right? This equals, right. No calc area method for class numeric. Okay, so we want to create a calc area. Okay, so first of all, actually, let's do something. Let's just create a default. And remember, the notation is generic dot method. So little side note here. It's usually, you usually don't want to be giving just basic function names something dot something else, because the usual notation for that is generic dot method. So that's why we don't give functions names with dots in it. Okay, so let's do calc area, dot default. Okay, equals function x, and this is going to do, let's have it print paste 0. So basically we're gonna have this just do essentially nothing unless we define it for a particular class. No calc area method for class space class X, and then we'll end with a period. And okay, all right. So now let's try calc area X equals 1. So it gives us a message now. Okay, great. No calc area method for class numeric. Similarly, no calc area method for class character. Cool. Okay. But I do want a calc area method for something of class circle. Calc area dot circle equals function X. And then what I want to do is return pi times X $radius squared. Okay, why the $? Okay, so so basically, when we get into something that creates an element of class circle, it's going to store it as a list. So, and then that thing is going to be the element that we're going to be working with to define different circles will be given by an argument named with radius. I'm kind of jumping the gun slightly when I'm doing this, but anyways, we have an area method, and we'll come up here when we do rectangles and triangles. Okay, calc perimeter. So same idea, but I want perimeter. I may not do as rigorous checking and as rigorous making my code outside of function environments for this, just since there's a lot of stuff to cover. Okay, so now I'm creating a new generic for calc perimeter, and calc perimeter default. Okay, no calc perimeter method for class blah, and calc perimeter. Okay, and I believe the equation is 2 times pi times X radius. Okay, so let's see here. Let's try, okay, let's not get too far ahead of ourselves. Okay, so for each class, make a constructor. So let's do something, we'll come back to this, but let's just, we'll build on these constructors in more detail. You know what, I'm gonna, constructors. Okay, so I'm going to make a function which creates a structure that will be given the class circle. Okay, so this, essentially going to take an input radius, and it's going to make a structure list radius equals radius. I did this, I briefly introduced this structure command in one of the previous videos. Here it is again. Class equals circle. Okay, so let's see what this looks like here. Okay, so new circle. New circle. Oops. Radius equals 2. Wait a minute. I may need to clear my global environments because I have an active R session with. Yeah, we're gonna have to do that. That shouldn't print out. Haven't created a print method yet. Okay, this is what it should look like. So basically, this is gonna create a structure of class circle, and right here it's just a list with one element radius, and then it has this attribute class circle. But now I could do stuff like this. Calc area, this thing. Oh, I need to, you see, I can do calc area now on an so I've created this object of a certain structure, just a list radius, a class circle, and I've created a calc area generic that has a default function for circles. Okay, similarly, I can do calc perimeter. Cool. And let's, oh yeah, let's do 3 just to get different things. Okay, great. And I'm gonna create a new section called testing. Okay. Circle, and I'm gonna do, what should be a good name for this? How about proper usage? And then we'll get into errors, which right now there aren't any. So right now you could do something like -3, and it will work even though a perimeter of a circle can't be negative, and yeah, stuff like that. Okay. How about we do, let's see what happens if we do this. 2, 3, don't need negative. Right, so now a circle can't have 2 radiuses. Of course, the understanding could be that it's 2 different circles, but we want to just work with just one circle. So these don't throw anything yet because we haven't actually built anything that checks whether or not the circle that we're creating is actually valid. Okay, but before we get to validation, which is rather tricky, not tricky, but tedious, let's do print methods. Okay, so I have calc area, calc perimeter. Get this organization is gonna be nice. Okay, let's do print. Again, Control Shift R. Okay, I need to create a print dot circle. So print method for objects of class circle equals function X. And this is just going to print some description about this particular structure, this object of class circle. And how about we just give it a description in words. Paste 0. For the difference between paste and paste 0, you can check out on your own. Okay. This is a circle with radius space X $ radius, right? And then period. Okay. Run it. So let's go back to our new circle thing here. Okay, so you can see that this is a circle with radius 3. So when we, so remember there's a difference between the object itself and what is printed. The structure here. What? Excuse me. Oh, how about this? Radius equals 3. Okay. So you can see that the structure tells us that this is a list with one numeric element given the name radius and that there's an attribute class equals circle. But what is printed is just this description. So it's not the object itself, it's this print method that we wrote to describe the object. But the object itself is this list with a class defined as circle. Okay, so good to know. All right, and I can, oh yeah, I had this up to make sure that my face wasn't covering anything, but it looks like it's fine. Okay, where was I? So we have constructor, oh, we need a validator. So basically what we have now is we have a way of constructing objects that are circles. We have a way to print what those a description of what those objects are. And we have a generic method, calc area and calc perimeter, for which we've defined specific functions for objects of class circle to do the usual things. However, we have this case where our current way of doing things allows us to output nonsense circles. Okay, right, or nonsense areas and perimeters of circles. So we need to fix that. Okay, so we're gonna do, and like I said, we're gonna come back to this. So basically the idea is that we want this function, which allows us to construct what a circle is, to actually construct things which are circles. And we need an intermediary step for validators. This is going to be a little tricky. Okay, so what we want to do is validate underscore circle equals function x. Okay, so what we're going to do is we're going to just rule out things that aren't circles or conform to sorry, I should say rule out things that aren't circles as we understand them, just a positive single radius, but also keeping in mind that the way that we are communicating this circle, building it up from the ground from R, is in this in the form of this list giving a particular class name. So we are going to throw error messages for anything that is not a valid circle. So first of all, knowing that an object or valid circle of class circle in the way that our constructor function is building it. So is.list needs to be a list. Length of that list should be 1. So I shouldn't have multiple elements. And the names of the x should be radius. Okay, so if that is the case, we will throw an error message. A circle must be a list with one named element radius. Okay. And I'm gonna just move this over. You know what? I'm just gonna do this. Okay. Oh, that feels much better. Okay. So that's kind of takes care of the structured part. We also don't want to consider circles, or we don't want to consider things that aren't of class circle. So, okay. You know what? I'm going to write these as sentences. A circle must be class circle. Okay, great. So now let's get into some of the technicals for like what a circle is. Okay, so if not is dot numeric, so the radius should be numeric. And should be length 1. So we want to rule out cases where radius is not numeric or has a length greater than 1. Actually, I should say different than 1. radius not equal to 1. Okay. So this will rule out cases where if I define two radiuses, right? Which we just want our constructor to create one circle, for which then we can calculate the area and the perimeter of. Okay, so stop a circle. A circle is radius. Must be a length 1 numeric vector. And we're not going to care too much about integer versus double here. Okay. And the radius should be positive. If x $radius is less than or equal to strictly positive. I guess technically it could be 0, but that's not interesting. So we'll just restrict to positive. A circle's radius must be positive. I'll just add strictly positive. Okay, just to be precise. Return x. Okay, so if it passes all these things, so again, if any one of these conditions is satisfied, it's just going to break. It's going to break out of this and just produce the error message. Otherwise, it'll return x. So let's now take our validate function. Actually, let's validate. Let's run it. Validate circle x equals 4. So you can see it must be a list. Okay. X equals list 4. Okay. Radius equals 4. Must have a class circle. So you can see now that this thing doesn't have any of those things. Let's see if I were to y equals this, class y equals circle. Wow, so now that passes. This is a circle because, so now everything was satisfied. And so the object, a list with element radius of class circle, is now just displayed, and the way to display it is given by our print function, which we have stated above. Okay, but that's tedious. So we could do that. We have it at our disposal. But now I'm going to put the validate circle thing inside here. Okay. Okay, great. So then our constructor will create valid circles, or will return valid circles or one of these error messages. So now with this structure in mind, let's see what our test cases look like. Okay, new circle, circle with radius 3, good. See the structure, don't need this anymore. Calculate the area, calculate the perimeter. Now, good. So now we can see our calc area function breaks because our circle function broke because the radius was not correctly specified. And then for this case, circle can only have one radius. Circle's radius must be a length 1 numeric vector. Okay, great. So that is how to create a circle, I guess, function, checker functions, validators, constructors using the S3 system, where we started with the generic method. Note that our generic method works for anything, has the potential to work for objects of any particular class because we wrote a default class for it. So now what we can do is we can use our calc area, calc perimeter functions on objects of other classes. We just need to fill that in. So let's go back to our prompt here, because we also want to do rectangles and triangles. Okay, so how about, should I do both at the same time? Yeah, okay, so we have one pass through this. I'm gonna go through, yeah, I guess I'll go through both when it's easy, and then I'll highlight differences when it's not. Okay, so we need calc area function for rectangle and then triangle. Okay, so, okay. Note that here we are going to have, okay, so in the rectangle we have length and width. I mean, the area of a rectangle is just length times width, correct? I think so. That would be bad if we got that wrong. And then for triangle, it says elements A and B. I guess one is the height and one is the base and one is the height. Okay. Okay, keep in mind one thing. The class will only be used to store right triangles for simplicity. Good to know, because that's going to make things a lot easier. Oh, and this should be divided by 2. 1/2 base times height, right? Okay. Okay, so now I have a few area functions. Okay, perimeter. Calc perimeter dot rectangle equals function. Okay, I believe it's 2 times x $length plus 2 times x $width. Okay. I could have just typed this out. That would, okay. What do I do here for perimeter? Triangle. Okay, so I'm given 2 sides, and I'm gonna leverage the fact that this is a right triangle, so I need to compute the hypotenuse. So that should be square root of x $A squared plus x $B squared. Right, that's Pythagorean theorem, correct? I think so. Okay, so now I have these different methods. Okay, print. Yeah, we'll do, let's go to constructor. Okay. New. Jeez, silly me. New rectangle equals function length width. Let's just do structure for now, and we'll come back and fill in the validator. And we will do list length equals length, width equals width, and then we'll do class equals rectangle. Okay. Okay. And then now it sort of makes, so now we know that we're creating a list with 2 elements, one length, one width, and a class of rectangle. Right now, no further specifications, whether it's valid or anything like that. We haven't done it. Okay, but we do have a perimeter and area function for objects of class rectangle, which we can now create. Okay, but let's do a print function first. Print dot rectangle equals function x print paste 0. Okay, this is a rectangle with length x $length and x $width. Is that it? Yeah. It's actually pretty easy. So let's do that. Oh man, I am sorry. I'm bouncing all over the place. I just thought that this one was easy. So A equals x $A and x $B. So basically, at first, I didn't know how to generalize the constructor function from a list with one element to two. And then once I did that, now I know what the general structure of a rectangle is. And now I'm doing these print functions, and I know I need to do it for a triangle as well. I'm already here, so it's pretty easy to just, oh, you know what? This should be, oops, and width. Okay. And now I need to remember that I need to actually create a constructor for triangle. New triangle. And this is using like this base height thing. A equals A. B equals B. Plus triangle. Okay. Just run everything. All right, so I'm just gonna Control F within this selection and replace everything from circle to rectangle. Okay, so now let's see what happens. I ran everything. Right. Length equals 3, width equals 2. This is a rectangle with length 3 and width 2. That's our print statement. Great. Let's just copy this. This is our area. Great. So you can notice that calc area and calc area here are working on different objects, right? But I don't need to specify different function names for them. I've created a method that works for objects of different classes and does different things for those objects of those different classes. That's how I'm defining everything with the S3 system. Okay. And then also perimeter. Looks good. Let's that's not gonna work. Let's place a -3 here. Oh, well, it works. Doesn't throw any error messages, right? Well, that's because we haven't given it any yet. Width equals C to 3. Need one more, okay. Oh, it just works. Silly. Okay, so what do we need to do? We need a validator. We have everything else. And then we need to go back into our constructor and add it in here so that we construct valid things. Okay, so this is tedious. And so what I'm going to do is just copy in the correct code. Validate rectangle. So let's go over it. We want our object of class rectangle to be a list. We want to have 2 elements. Remember, it has a length and a width, and those elements need to be named length and width. So a rectangle must be a list with 2 named elements, length and width. Class needs to be rectangle. A rectangle must have class rectangle. The length and the width must both be numeric. The lengths and widths specified must be length 1. These are actually the same error message. A rectangle's length and width must be length 1 numeric vectors. Let's actually, okay. And must be strictly positive. Okay, validate rectangle function. Nice. Now let's do that. Oops. Ooh. Validate rectangle. Oh, that's right. I need to actually. Okay. Good. And let's do validate triangle. Same thing, or just copying code that I've already written to do the task. Otherwise, this is going to be tedious. All right, so validate triangle must be a list. The list must have 2 elements. Those 2 elements must be named A and B. Triangle must be a list with 2 named elements A and B. Class of a triangle must be triangle. The arguments must be numeric in length 1. And a triangle's A and B must be strictly positive. Okay, let's add it. Validate triangle. Okay. Wow, this is a lot of code. Let's run everything. Great, and now let's do our testing for rectangles. Okay, those cases worked last time. Let's see if our error, okay. Good. The rectangle's length and width must be strictly positive. The rectangle's length and width must be length 1 numeric vectors. Looks pretty good. Okay, now let's test triangle. I believe I've already done everything, right? We have an area, we have a calc area specified for triangles, objects of class triangles. Perimeter, calc perimeter specified for objects of class triangles. Print method for objects of class triangles. Wait, did I do this? Proper usage, new, yeah, rectangle with length 3 and width 2. Okay, good. Just a sec. Print. You know what? Yeah, I don't like that. I'm gonna, wait a minute. Periods at the end of my sentences would be nice. Okay. Let's go back to the bottom. There we go. A little bit better. Okay, so I have area, perimeter, functions for objects of class rectangle and triangle. I have print methods, and we just added in validate, and we have constructors, where those constructors build in the validation functions, and now we're on to testing. And we have testing all the way through rectangle. So now, just to finish this up, triangle, proper usage, new triangle, A equals 3, B equals 2. This is a triangle with A equals 3 and B equals 2. Oh my gosh, that space after the equal sign. Shoddy work right there. Now let's try it again. Much better. Okay. Calc area function. 1/2 base times height. Looks good. Calc. Oh, geez. Silly me. Oh, no, that was right. Perimeter. I'm sure it's right. 3 plus 2 plus 9 plus 4. Okay, it's good. All right, so on our proper use cases, things are looking very good. Now let's try calc area, new triangle, A A equals 3, B equals -2. Actually, no, just to be consistent. Not like it matters. Triangle. Bad. Where is my error message? Oh, validate. Triangle. Spelling can be hard sometimes, can it? Triangles A and B must be strictly positive. Okay, great. And now let's do 3, B equals C, 2, 3. This is gonna drive me crazy. Okay. A triangles A and B must be length 1 numeric factor. Okay. Good, we did it. Okay. So I think we have everything. Let's just check. Validator. Function calc area, calc parameter that calculates the parameter. Proof new generic add default methods that throws an error with a message stating that no method exists for class of the inputs. For both new generic, add a default. Ah, good. We already did that. Yeah, because we created these defaults. No calc area method for class. Okay. I think we have everything. I'm confident enough to try to submit this. I submitted it last time. It took it a little bit to run. Actually, it didn't take that long. I could have just stayed on there. Let's make sure this time. Oh, you know what? I think what I did last time was I didn't actually push the button. I pushed the button once and it then activated the internet, but I actually need to push it twice. Oh, geez. Okay, well, it does take a little bit of time. It's still grading. Wait, what happened? Okay, give me 1 second. All right, I'm back. Okay, so what ended up throwing it was having the testing section run. It's very annoying. Okay, so anyways, okay, so just to show what the final output is, I have an area method being created, area generic, which we define for objects of all classes, and then we write specifically interesting things for objects of class circle, rectangle, triangle. Same thing with perimeter. Then we create print methods to provide some descriptions of the objects that are going to be created when they are these particular class. And then we create constructors to actually build these classes, but note that we are building valid objects of these classes and having it flagged for error messages when they don't conform to what we define as valid. And to make those determinations, we have these validator functions to decide when an object is of class is a valid object of class circle, rectangle, triangle, etc. And then that's it. And then we had somewhat extensive list of testing cases that could not run through the autograder. Okay, that's it. It's a lot, but this is a nice look at the S3 system, which is something that you are going to use all the time in R. You use it when you just type in a number. Not something that you're going to actually program with necessarily too much. But it comes in handy. Like we sort of know that under the hood of everything we're doing, there's a print statement, and sometimes it is, like in my experience, developing software to implement some sort of statistical technique. If it's model based, you want to actually create print functions to describe the objects that you are storing, much like linear models would have one. So, and like summary tables, that kind of stuff, creating your own summary table. So there's a way that R displays that information, and it's very, for those of us who use R quite a bit in analyses. So like if I do, sorry, I'm starting to ramble, and I know this is really long, but if I were to create R norm 5, y equals R norm 5, then LMY X, right? This is a object of class LM, so it can be printed. And this descriptive information is natural for a linear regression model. If I had summary model, I get summary output. This looks ugly because the screen's too small. Still looks ugly. Let's do this. Okay, now it doesn't look as ugly anymore. Okay, so this particular summary table. Well, if I were to change it to GLM, which the default is a generalized linear regression model, so the default is linear regression, so I don't need to specify anything. I get a different type of object printed out, but it's very similar to the one with LM. And I get a slightly different summary table, but it is still nonetheless very similar. Okay, so like this kind of information is the same in both of these. Okay, so long story short, and this is the S3 system working. This is print statement, summary, doing different things for different objects. Here is we have prints and constructors and validators doing different things for different objects. And then where we get to an area function, calc area, calc perimeter, doing different things for different objects. Okay, I've talked too much. It's time to go. Thank you for paying attention and watching, and take care. All right, bye.